Good day everyone. Welcome to the video presentation of Mission 4. We are SEEE3533 Communication Principles Section 2 Group 12. My name is Chiu Jing Wen, and let me introduce about what is communication system. Before we start, let's think about what is communication system? How do you want to send data or information to someone who is far from you? If the information that you want to send is your voice, how to make sure that what you are saying is understood by your friend? Well, communication system will be the technology available to solve these requests. It is important for our daily activities like social connection, information access, and business operation. Communication system is the process of sending information signal from one point to another point, involving three important processes, which are transmission, receiving, and processing of analog signal and digital signal. Some example devices in communication system are satellite, radio, cellular phone, and fiber optics. Now, let's make a simple scenario in a basic communication system. Let's say you are making a phone call. The original talking voice, when making a phone call, acts as the input signal ST. This is the natural analog signal containing audio information. The microphone on your phone serves as the input transducer. Its function is to convert the input signal into electrical signal, which is suitable for processing and transmission. After that, the signal is sent to the transmitter or modulator. The result is the modulated signal, which is sent to the medium. The transmission medium can be wired or wireless. The example for the wired transmission medium is copper or fiber optic cables, and the example for the wireless transmission medium is electromagnetic waves. In the case of a phone call, this could be a cellular antenna or the telecommunication tower. The cellular antenna on the phone converts digital signals into electromagnetic waves for communication with nearby telecommunication towers. During propagation, the modulated signal might experience noise which can distort the transmitted signal. That is why we need receiver or demodulator. The receiver or demodulator will perform demodulation to recover the modulating signal to represent the original signal. Finally, the output transducer such as loudspeaker converts the modulating signal into a usable form, which is the output signal. In a phone call, for example, this is the sound you hear through the earpiece, closely replicating the original voice. Next, let's look at what is modulation. Modulation is a signal transformation to format suitable for transmission through a chosen medium. Modulation often involves another signal, which is carrier. The message or modulating signal modulates the carrier to produce the transmitted signal, modulated signal. After the modulation, the signal will shift to higher frequency, which is good for long-distance signal transmission. There are two types of the modulation, which are analog modulation and digital modulation. For analog modulation, it transmits analog wave from low frequency signal to high frequency signal. It consists of amplitude, frequency, and phase modulation. For digital modulation, it is the process of encoding a digital signal into an amplitude, phase, or frequency of the transmitted signal. It consists of amplitude shift keying, frequency shift keying, and phase shift keying. Now, the first analog modulation is the amplitude modulation. Amplitude modulation, AM, is a fundamental modulation process in communication system. It will result in change in amplitude of the carrier signal according to the modulating signal. Next is the frequency modulation, FM. In frequency modulation, modulated signal will have higher frequency wave at the instant of the peak of the modulating signal. Next is the phase modulation. For phase modulation, the modulation signal will have higher frequency wave at the instant of the rising edge of the modulating signal. Now, let's look at the radio-digital modulation. Radio-digital modulation is the modulation technique which is similar to analog modulation signal, in which the modulating signal will vary the amplitude, frequency, or phase of the carrier signal. The only difference is modulating signal become digital signal. The task of the carrier is to shift the baseband signal spectrum, digital data, to a higher spectrum around the carrier signal. This is the block diagram for digital transmission system, whereas the series of bits will be produced after line coding for digital modulation. There are three types of digital modulation, which are ASK, FSK, and PSK. For ASK amplitude shift keying, the advantage is bandwidth efficiency, but it has more noise. For FSK, it has less noise but larger bandwidth. Larger bandwidth will result in limited availability for spectrum and high power consumption. For PSK phase shift keying, it has less noise than ASK and FSK. It also has similar bandwidth to ASK. For PSK, the digital signal is used to switch the phase of the carrier signal. From here, we can see that there is phase change for bit 1, but there is no phase change for bit 0. In binary phase shift keying, when there is no change of bit, like the series of bits are odd 0, 0, 0, 0, 0, that means there is no phase change. Next, let's get to know bit rate and baud rate. Bit rate refers to the number of bits transmitted per second. It is measured in bits per second. It indicates how much data is being transmitted. For example, a system transmitting 1000 bits per second has a bit rate of 1 kbps. Baud rate refers to the number of signal changes or symbols transmitted per second. It is measured in bauds, symbols per second. It indicates how many times the signal changes, for example, amplitude, frequency, or phase changes. The example for baud rate is a system with 1000 signal changes per second has a baud rate of 1 kbaud. ASK and FSK typically uses one frequency for binary 0 and another for binary 1. Thus, for ASK and FSK, baud rate is equal to bit rate. Whereas, PSK can encode multiple bits per symbol by using multiple phase shift. For example, binary PSK, quadrature PSK, and egg PSK. The relationship between baud rate and bit rate depends on how many bits per symbol. This table shows the mapping of quadrature PSK signal using gray code. The changes of 1 bit will result in the 90-degree phase change of the signal. Just now we learned about different types of analog modulation and digital modulation. There is also a combination of them. For example, QAM, quadrature amplitude modulation. QAM is a modulation technique used in digital communication systems that combines amplitude modulation and phase modulation. It allows the transmission of more data by encoding information in both the amplitude and phase of the carrier signal. QAM uses a constellation of 2 points on a 2D plane, whereas x-axis represents the amplitude of the in-phase I component, and y-axis represents the amplitude of the quadrature Q component. There is 4 points. Each point on the diagram represented a unique combination of amplitude and phase, which corresponds to a specific data symbol. For ASK, FSK or binary PSK, they typically transmit only 1 bit per hertz, which has low efficiency. For QAM, it transmits 2 bits per hertz, doubling the bandwidth efficiency compared to binary PSK, ASK, and FSK. Next, let's look at the recent advancement in the telecommunication technology. The first one is RFID, radio frequency identification. One of the common application of RFID is contactless payment. Next is artificial intelligence AI. It provides predictive analytics, automation, and improving communication system like network optimization. We also have visible light communication (VLC). It is a wireless communication method using visible light, like LED. It can be applied to indoor navigation. And the last one is the 5G technology. It is applied in smart cities, autonomous vehicles, and IoT devices. Next, let's look at the impact and benefits of the telecommunication technology to the society. Firstly, telecommunication advancement benefits the healthcare, as remote surgery and high-speed diagnostic and report can be achieved. In the environmental monitoring, telecommunication technology can facilitate advanced sensor networks to track climate changes and pollution levels. For education, telecommunication technology enables immersive learning experience through augmented and virtual reality. For public safety, telecommunication advancement can provide a real-time communication between IoT devices, enhance disaster response, and traffic management. There are some misconceptions towards telecommunication technology. First, some people think that telecommunication technology is bad for health, with the rumor of mobile networks like 5G towers emit harmful radiation causing cancer or infertility. In fact, telecommunication technologies comply with international guidelines, regulate safe radiation exposure levels. Studies confirm that non-ionizing radiation used by the telecommunication devices does not harm human tissues. For the safety and legal concern, there is misconception that advanced telecommunication like IoT and 5G will lead to mass surveillance and privacy issues. Actually, the increased use of data comes with stricter privacy laws and encryption technologies to protect user information. Next is the cultural and social impact. There is a misconception where advancement in telecommunication only benefit urban population and widen the rural-urban divide. This is not the truth because in Malaysia, the Malaysian Communication and Multimedia Commission (MCMC) has implemented projects such as Kampung Tanpa Wayar and Universal Service Provision Program to bring internet access to rural villages. For example, in Sabah and Sarawak, satellite internet and community internet centers have significantly improved access for indigenous communities, enabling them to participate in e-commerce and access digital education resources. In conclusion, telecommunication has transformed the way that we connect, learn, and work, becoming a vital part for our daily lives. With exciting advancements like 5G, IoT, and satellite internet, the future holds endless possibility for faster, smarter, and more accessible communication. The advancement of telecommunication will keep bringing people closer together and creating a more inclusive and connected world. That's all for our presentation. Thank you.